Hey, so in this next section we will discuss file streams. We've already discussed the concept of what a stream is. A stream as an abstraction that acts as an interface between the C++ program and some input or output device. Those input and output devices can include the console, files on a drive, or the keyboard, and the programmer uses the abstraction for input and output and is not concerned with how the actual input-output is achieved. We are familiar with the global stream objects at this point, cout, cin, and so on from the standard namespace. We don't have to instantiate those objects, they exist already and we can just use those. This is the example that I showed previously. We have some input device such as a keyboard or a file. Then we have the abstraction such as the cin object, and that is what we as programmers interact with in our program code, as we have seen up until this point with cin and cout. Then of course we also have some output such as cout, and through that output stream abstraction we interact with the file, and of course that is what we are concerned with in this section, input files and output files. Alright, so streams and I/O referring to input and output. We can do input from the keyboard as we've seen using the cin stream, and we can also do input from a file on disk. Now the standard ifstream class is used for input file streams, and as with the cin stream we can use the stream extraction operator to extract from an input file stream, as we'll see. We've also seen that we can do console output using the cout stream. Now we can also do output to a file on disk. Alright, so we insert into an output stream, and the standard ofstream class is used for output file streams. And as with the cout stream, the stream insertion operator is overloaded to work with the ofstream object. So why are we concerned with files for input and output? Well, files allow for permanent storage. Output files remain after program execution. Input files can be reused multiple times, even by multiple programs. And there's no need to re-enter data each time the program is run. You simply read the data from the file and then do something with that data. Some calculation perhaps, and then you can either print that information out to the console again, or you can put it out to another file on disk. It's convenient with the files being on disk because it means that you can prepare the input for the program, or read and try and interpret the output produced by the program whenever it is convenient. That is, instead of typing in the input while the program is running, or reading the output while the program is running. So it's a more convenient way of dealing with large quantities of data. So in essence, a file stream is an abstraction or a class that acts as an interface between the C++ program and input and output files. Again, we as programmers don't deal with the files directly in our program, in our code. We deal with the abstraction or the class object. So what are the steps? What is involved in reading from a file or writing to a file, for example? Well, we would instantiate the appropriate class, ifstream, ofstream, or fstream, and I will introduce those and talk more about those as we go through the rest of the lesson. Then we connect or associate the stream object with a file. Then we actually want to check if the file has opened successfully. You may want to terminate or exit the program if that was not successful, so if the file does not exist, for example. Then you want to read from the file or write to the file, so in other words you want to interact with that file somehow. Finally, we want to close the file to disconnect or disassociate that file with the stream object. A quick example on the file stream. Again, we will run some programs on this in upcoming lectures, but just to demonstrate here the steps involved. In the main function, we are going to instantiate the particular class type, in this case an ifstream class. We instantiate that. Then we can either use the constructor or the open function and provide the name of the file, in this case text.txt, just some file name. As I will demonstrate, we can also provide the full path name, but we typically avoid that. So to the right on the stack we can see we have that object. Then we also have on the drive, on your hard drive, on your solid state drive, wherever it may be located, we have that file named text.txt. So in this way, as we can see with this arrow here in this illustration, the stream object is now associated with that particular file. So we do a check if that is open. If it is not open, then we may want to log some error message and also terminate the program somehow by returning or by using the exit function. Following the check, we actually want to interact with that file. So if it's an input file stream, then we want to read from that, so we want to extract from that. If it's an output file stream, then we want to write to that or insert into that. Finally, we want to close the file, and we can use the close function for that. And that's important because that will flush that particular stream, and then that will also disconnect or disassociate with that particular stream.